Hello everyone. Last class we learned about functions, okay? And now we're going to be considering a few of the ways that we represent functions, okay? So four main ways that we're going to look at when it comes to representing functions. And that's with formulas, okay? With graphs, tables, and with words, okay? So these are four ways that we're gonna take a look at when it comes to representing a function, okay? So first, let's take a look at formulas, okay? How do you represent a function with a formula, okay? So first thing we're gonna take a look at is polynomials. Polynomials, all right, are functions of the form p of x or f of x or whatever your function of x equals. So this is a polynomial right here. All this is, an example of this is like 5x squared plus 2x plus 3, okay? So you're going to have your x's, okay? And you're going to have x's to some power, and you're also going to have some constants in the front of those x's, and you may or may not have a constant by itself as well, okay? That's all a polynomial is, all right? Now, a rational function, so polynomials, those are just a type of function, okay? They're functions that look like that, okay? Rational functions look like this. P of x over q of x, okay? Where p and q are polynomials, okay? So this is a polynomial and this is a polynomial, okay? That's what a rational function is, okay? Next up, algebraic functions. Okay, so algebraic functions are just functions that are constructed using all of your arithmetic operators, such as addition, subtraction, multiplication. I put a dot for multiplication because if I did this, it's very easy to think, oh, that's x. But I'm going to leave this as this because it's multiplication, division, and also square roots. What are roots? Well, all a root is if you said 5 in here, okay, it's whatever number times itself equals 5, okay? It's like the opposite of squaring. An example of an algebraic function could be f of x equals the square root of 2x to the 3 plus 5, okay? Because here you can see you have, this is multiplication right here, and you might say, oh, that's an exponent right there. Well, all that is x times x times x times x, or 3 times, you know? So that's multiplication, addition, and we have roots here. So this is all constructed with these basic operators, okay? And you could even say this. Boom, that right there. Now let's take a look at exponential functions, okay? Exponential functions, now these are functions that take the form of this. F of x equals, we'll say b to the x, okay? So all this is when you have, we even say like 5 to the x, okay? When the x is in the exponent, okay? Now with these, you also have logarithmic functions, okay, that take the form of f of x equals log base b of x, where b is greater than 0, okay? So with this, you're going to need to know logs and natural logs, what that is, okay? You can go ahead and take a look at my other video on logs. Just look up PDMaths, logarithm, class. And we go over logarithms, but there's logarithmic functions, and then there's also the natural exponential function, and all that is e to the x, okay? E to the x is going to come in a lot in this class because it's a crazy number, it's a crazy function, and you will see why it'll come up a lot in this class, especially since this class is all about derivatives and integrals and stuff like that. So next up, trigonometric functions, and these are your sines, your cosines, your tangents. With these, once again, go ahead, take a look at the trig class that we have if you're not familiar with these. These are pretty simple. Once you get these, then they're gonna play a role in this class as well, okay? So we got trigonometric functions, and yeah, so these are all the types of functions, and all of these are a way to represent a function, okay? All these types of functions that I just listed, polynomials, rational functions, algebraic functions, exponential functions, trigonometric functions, these are all just formulas that represent functions, okay? Now, instead of a formula, graphs, okay? I'm sure you can see how a function can be represented by a graph, right? If you have y and x, you can represent a function by graphing it with a line. Now, to see if it's an actual function, in the last video you can use we went over how you can use the vertical line test to see if it's an actual function. And yeah, so I want to mention this. In the last video, I went like this, and I asked, is that a function? And we said no, because it doesn't pass the vertical line test, right? That does not mean it can't be represented by a formula, okay? There are formulas to represent circles out there, okay? And those are not necessarily, those aren't necessarily like functions, okay? Those are just equations that can represent a circle, okay? That doesn't make it a function, okay? Remember, what is a function? A function is something with an input that has an output, okay? A domain and a range, okay? So as you can see here, we can use a graph to represent a function, right? Now, let's take a look and see how can we use a table to represent a function, okay? If you had a table, okay, and said this is t equals seconds, okay, and this we'll call meters, okay? And if you said 0, 1, 2, 3, 4, 5 seconds, okay, and you were trying to describe how an object falls, okay, in meters. So if you said at 0 seconds, your object is at 0 meters, okay? And let's say at 1 second, it falls 1 meter, okay? Now let's say at 2 seconds, it's at 2.5 meters, okay? Now say at 3, it's at, 6 meters, okay? And at 4, we'll say it's at 11 meters, all right? You have all these values for all these inputs, okay? This right here, you could see how you can use a table to represent a function, okay? Because if you were to plot these values on a graph, because if you see, okay, 0, 0, 1, 1, when it's at 2, it's at 2.5. When it's at 3, it's at 6. 1, 2, 3, 4, 5, 6. When it's at 4, it's at 11. Okay, so our graph looks something like this. Okay? Now, what does this graph tell us? We're going to learn how to read graphs and know the actual meaning of them later in the class. But for now, you can see how a table can represent a graph. Okay, this is a position versus time graph right here, because position in meters and yeah, but that'll play into other stuff. But there's a table, okay? And lastly, words. Okay? You can represent a function using words. How can you do that? Well, an easy way to think of how you can use words is... Okay, so words are the most basic and most useless way of representing a function, because typically you start off by using words, and it might even be a word problem, right? Say, okay, you have a tank of water that has 50 gallons in it, and it's decreasing at a rate of 5 gallons per second, okay? These are all just words that I'm saying, and what you would then do is you would then write it out. You would either graph it, and then you would either make a formula so that you can actually analyze what the words are, okay? So words are the most useless way of representing a function, but they're the most practical because that's what you start off with. You start off with the words of describing the function, and then you say, okay, now we can either make a table or we can make a graph and then make a formula that we can then analyze algebraically, okay? So I'm going to end this video out with a quick review, okay? There's not going to be any problems for this video because there's nothing really to ask other than what did you understand from this video, okay? So what do you understand from this video? There are many ways to represent functions, okay? There are formulas, there's graphs, there's tables, and there's words, okay? Words are the most basic and practical way of representing a function, okay? These are like word problems, okay? And then when you go to tables, tables are with how you plug in values. You typically go like with one unit at a time, and then you plug in a value for that time frame. And then a graph, I'm sure you can graphs are definitely visually helpful to physically see what your function will look like. And formulas are the most mathematical way of representing a function. These are the most, these are what you're gonna use to represent a function in this class, okay? Formulas. And I'd say if there's one thing to leave this video with, it's to understand what a polynomial is, okay? All a polynomial is functions that have x squared, x cubed, x to the 4, x to the 5, or x. It's just not necessarily with just x's in them, okay? But with an x to some exponent, okay? A polynomial can be written as, okay? So all these a's and n's, I'm sure they're probably confusing if you don't understand those, but all it means is some constant, okay, with x raised to some number, okay, plus whatever constant. This an minus 1 is just another constant, okay? Don't worry about what that actually means, but some other constant times x to the n minus 1. So whatever this is 1 less, okay? And then plus this plus some constant times x plus another constant, okay? Now that doesn't mean you can't have x to the 5 plus, say, x to the 2, okay? This is also a polynomial, okay? All that, just because there isn't like a x to the 4 and x to the 3, oh, no, this isn't a polynomial. No, it's just anything that can take this form, okay? Because if you were to really see, this is just 1, the constant here is 1, plus 0, that's the constant, x to the 4, plus 0, x to the 3, plus 1, x to the 2, okay? If we were to really write it out, that's what it would be. But there's just zeros there, so you don't say that, okay? If there's one thing you take away from this video, it's that this is what a polynomial is, because polynomials will be used all throughout this video, and I don't want you, or all throughout this class, and whenever you hear the term polynomial, or is this a polynomial, is that a polynomial, just understand it's just a type of function, okay? It's just a type of function. It's just like trig. It's just like sine and cosine, okay? It's just a different type, okay? This is a very simple type of function, okay? So with that being said, I want to thank you for watching this video. Keep it up with this math. Hopefully you're learning something. Go ahead, comment down below if you want to see any other types of videos. If you want to see, whatever you need help with, go ahead, message me. And I'm here to help you with your math. Thank you for watching. That's it for this video. Go ahead and move on and learn more. Let's go.